Hello everyone, my name is Kenan Marim Rashida and I am honored to present the project we developed in collaboration with my teammates Boukham Sara, Tahman Fatih, Mwelki Rihab, Belhiboud Mahdi and Luwali Samir Abdel Badi'. This project was carried out under the supervision of Professor Atari, whom we thank for his guidance and support. Our project focuses on the design of a mechanical vibration measurement system aimed at implementing a predictive maintenance strategy. Our project involves developing a system capable of measuring the mechanical vibrations produced by a machine during operation. So, by analyzing these vibrations, it is possible for us to detect anomalies such as imbalance or mechanical defects at an early stage. The goal here is to implement a predictive maintenance solution, which means taking actions before a failure occurs, in order, of course, to reduce unexpected downtime, extend equipment lifespan, and optimize the maintenance costs. Our video is divided into two parts. We have first the software section and the hardware section. We will begin with the presentation of the software part, along with the experimental demonstration which will be presented by Dahman Fatih. Then we will move on to the hardware part, especially the printed circuit board, our PCB, which will be presented by Boukham Sara. Thank you so much for your attention. Let's get started.
This Python program simulates a vibration detection system on three axes, X, Y, and Z. It generates simulated sensor data, converts them into acceleration value, ng, and smooths the data using a moving average to reduce noise. Vibrations are then inferred by observing the changes between successive acceleration readings. In other words, rapid variation in acceleration are interpreted as vibrations. If the vibration intensity exceeds a certain threshold on the one of the axes, an alert is triggered. Finally, a real-time graph displays the vibration levels on each axis. So, here is our washing machine where we will do our test. Here we have the EDXL335 sensor. First, we start the washing machine, then we place the sensor on top. After that, I will start the program and we wait for the machine to start working. We will soon see the signals. For now, we will notice that the vibrations detected are weak because the machine is not moving much yet. But however, this shows that the project is working correctly and we have successfully detected the vibration.
Hello everybody, today I'm going to be explaining our predictive maintenance project focusing on both the circuit diagram and the PCB we built. So as we can see here, at the center of our design we have the ATmega 328P microcontroller. It is the whole brain of our system. It's going to be reading data, processing it, and controlling the output. To keep it running accurately, we added a 16 MHz crystal oscillator with two small capacitors for stability. Next, we added the ADXL335 sensor, which is going to be detecting vibrations in three axes, X, Y, and Z. And then we connected it using a pin header so we can plug it or remove it easily. We actually also added a 3.3 regulator, which is the LD33CV, because our sensor works on 3.3 volts. And to power the board, we used a mini 316 voltage regulator to step down the input voltage to 5 volt, and we added several capacitors to stabilize our power. As you can see here, we also added a red LED as a simple indicator, for example, to show when the system has an error, for example.
This project represents the result of our collective efforts and dedication. Thank you for your time and consideration.